Well, let's talk about the countercurrent movements of the loop of Henle. So if we look at the loop of Henle, there's a descending loop and an ascending loop. And really, they almost work backwards in a way. I'm going to start with ascending loop first, if that's okay. And then I'll go back to descending loop, because it'll make a little more sense. So ascending means going down, descending means going back up. Descending loop is going to be a little thicker than the descending loop, excuse me, now you got me. And ascending means going up. This one's going to be a thicker loop, this one's going to be a thinner loop. And what the descending loop is going to do is it's going to reabsorb into the body sodium, potassium, chloride from the nephron into the red blood cells, into the capillaries. It's impermeable to water, meaning water can't really come into this area or out. It contains a high osmolarity for the renal medulla, and it basically does makes more filtrate, which, you know, really what I'm trying to say is we have a lot of active transport going on this side, and it's designed to pump these things out. And you'll notice that these are all ions that attract water. Well, now these ions are going to be floating around this side of the nephron. So what's going to happen is when water comes down this way, it's going to see all that salt at this area. And remember how salt and water come together? So what's going to happen is water is going to start to come out and start to go into this area. And what's filled with this area is a bunch of capillaries. And they're going to help reabsorb water. So if we look at this again, now that we can actually see it, keep in mind this is what it really looks like, with a bunch of capillaries and stuff here, and tons up here too. But I'm just going to focus in on this guy because he's got a little clearer loop of Henle. So, oh, and his is backwards. So this is going to be the way down, this is going to be the way up, and eventually this is going to go up to the ureter. So can you notice how this tube is thinner and this tube is thicker, and ascending is for water diffusion, and descending is up, so that's going to be for salts and things like that. I think I said that backwards, sorry about that. So we're going to see that coming down, what this tube is so thin for is because water is going to come out, a lot of it. But the problem is, why is water coming out? The reason why is because on this side it's so thick, we're going to pump, 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 pump using active transport ions. And that's going to be the potassium, the sodium, the chlorides. And if there's sodium, potassium, and chloride in this area, that means this area is going to have a low amount of water. And this tube is going to have a high amount of water. And osmosis works because water wants to go from a high concentration to a low concentration till it gets to equilibrium. And what's going to happen is it's going to get dumped into those capillaries and return back to the heart eventually. So we go ahead and we have the loop of Henle, and anything that still makes it out of the loop of Henle is going to eventually become our waste products, and we're going to go ahead and push things out that direction. The countercurrent exchange, like we talked about, is going to suck out a lot of water. The distal tubule will be controlled by some hormones, but we have still one more chance at getting water out. Water is so hard to come by that we want to make sure that we get as much water out as we can. And what we're going to do is we're going to go ahead and be able to have one more chance at the distal tubule to go ahead, or the collecting duct, to pull water out. And we're going to be pushing it out through this countercurrent multiplier, because there's going to be a lot of salt in this area. And because there's salt in this area, water just sucks out and eventually leaves. And you could see that there's very little, these numbers really dictate how much really salt is in the area. There's not a lot up here, but as we get closer or line up to our loop of Henle, you can see that the salt concentration is pretty high. So when the salt concentration is pretty high, osmolarity is high too, and that's what's helping suck a lot of this water out, and that dumps it back into our bloodstream. So that's the big story, and the rest we'll talk about in class.